For you guys who don't know, this was my old rear pulley setup that I used to run on my Transaxle before I switched over to my current jack shaft setup. Pulley disc, spacer, spacer, pulley, come on, spacer, pulley disc, not needed. And this here is my extended pulley hub. This here basically just goes on the input shaft as your standard pulley, and then it allows you to bolt on various different sizes of rear pulleys. The pulleys do not come with the bolt holes in them, but all W style pulleys have the same bore. So on this hub here, I put a lip that is the same size as that bore, so the pulley actually has a register spot, so every single pulley mounts at the same position. That way you don't have to keep buying hubs for these and welding them on when you want to change, to a smaller pulley to go faster or a bigger pulley to slow it down. This has the same mounting position as a stock pulley, and basically it is extended, but I did that for my own setup because I wrecked my input shaft bearings on my last Transaxle, and I wanted to be able to support the input shaft with a extension. That way it would save the bearings. Now, I got to build one of these for an old YouTube superstar, Craftsman Crusher. He wants one identical to this. And this thing only consists of really two parts. You need a coupler, 5/8 diameter. That'll work. And an old hole saw blank for the flange. So we'll start with the flange here. I need to clean the burrs off this 1/4 inch hole in the center. I have a bolt that has the head cut off that I'll mount in the chuck, and then this slides onto the bolt. I'll lock it down with a nut. That allows me to clean up the outer diameter of this disc. It'll allow me to turn it to size, and then I'll put my reverse jaws in on my chuck, and then that'll allow me to clamp onto the outer diameter. Then I can go ahead, bore the center out to whatever this diameter needs to be, and put the step in, which is only going to be about a 1/16 down in on the face at whatever diameter that the W size pulley bore is. So the main burrs are gone on the 1/4 inch hole. Then I went ahead and cleaned up that big old honkering burr that was on the outer perimeter. The arbor. Come on. As you can see that the disc is on the arbor, it's locked down with that nut, and it's up against the jaws of the chuck. Therefore, it should be running fairly true. Not even ready yet. Help if I put a tool in. Let's see how much we got to go. I think it's cutting all the way around, judging by the chips. Yep, it's cleaned up. I gotta make sure that this flange overall diameter will fit inside this recess on the pulley. And it does. There's a little bit of wiggle room. So we are good. Plus 4-inch pulleys and up all have at least this amount of flange to it. Usually the bigger the pulley, the bigger the flange. So this flange will fit up to whatever you can buy with this diameter. A 3.5 inch pulley like this only has like a 1/4 inch, if that, flange space here. So there's not even enough room to put bolts in on like a setup like this. So now I gotta break the corners. Alright. Perfect. Well, I decided to come to the drill press real quick. Basically to hole saw the center out. That way I don't have so much boring to do on the lathe. This should be quicker. I went ahead, took a 1-inch nut and placed it underneath the disc here. That way when the hole saw goes through, it doesn't hit my vise. And there it is with a 3/4 inch hole in it. Well, that hole saw drill is way oversized, so that's probably closer to 1 inch. But yeah, that'll save some time. The disc is now mounted in the chuck. I have my reverse jaws in that you can see it clamps on the outside of the disc there. Boring bar is set up. So now I just gotta bore this hole out to 1.1/16. Ooh, 1.1/16. There it is. I gotta clean these burrs up by hand because I don't have a bit to go in there and chamfer the edges on the ID. No big deal. Hope you guys can see, but I have the bolt hole pattern thing laid out on this flange now. It's really not that hard to do. All I did was take a bolt, turn the head down so that the flange would sit on that turn down spot. And then while the bolt was in the lathe, I did put a little stink with the center drill in the center of it. That way my compasses here have something to rest in. Then I just set the radius and just go and spin the old part to put the diameter on there. Then I put a 6 bolt hole in this thing here, just because it's actually easier to lay a 6 bolt hole pattern out on something that's already finished than a 4 bolt hole, because all you have to do is once you have your diameter marked out on your part, you just take the same measurement, the radius, and you just put a center punch somewhere on that diameter, and then you take your compass and you just swing, and then you go to the other side and you swing over there, and then you center punch those 2 spots. Then when those are center punched, you go back and forth, and the final one should end up with an X perfectly. Oh, it's this one on the diameter, and then that's how you know if you got them right. And when you center punch these, center punch them lightly first, and then once it's perfect, go ahead and do a heavy center punch, which is where I am headed to. Alright, so now I'm on to the coupler here. I need to size it down in length first, and then I gotta put the step in for the disc to sit on. I'll figure out that distance later after I have it to size, but I do know I need to take it down to 1.1/16, however far in. I went ahead, changed my jaws on my chuck so I can hold this coupler, and then all I need to do is put my regular cutting bit back in. Oh yeah, I did remove the set screws already. You really don't want to machine across those. All right, about 1 3/4 thou run out. That's pretty darn good. So 49. Close enough. All right, so now I am going to start turning, we'll call it a shorter down for that disc to slide on, and I'm gonna rough it in real quick. And that is just get close to the finished length and the finished diameter. This machine does not have a stop on it, so for me to precisionally get a measurement on like the length of the lip, it'll take forever to go across each time. So it's quicker for me to just hack it in there and then take my time and clean up that last little bit. This thing is to size. Just like that. Alright. Okie dokie, got her all tacked together. Now all I'm going to do is weld around that top seam there. I'm not going to put any weld on the bottom. The top should be more than enough. And by the way, I am not a TIG welder, so let's see what this looks like when it's done. Well, yeah, we're getting close. I got it all welded up. Oh, wrong side. There you go. They're not my best, but they're definitely not my worst. I guess the next thing I have to do is machine the step in this flange here for the pulley to sit on. Oh yeah, there's one other thing. The factory set screw in the coupler is a little low. So what I'm going to do is go 180 from that and then put a new 1/4-20 set screw up towards the top of the extension piece. That way he has two options to lock the input shaft extension in. I got the part mounted up in the chuck. I dowel indicated in the bore the best I could, and I got it within 1.5 thou. So that's not bad at all. Doing it like this, saving the step for last and dowel indicating on the board is, to me, the best way to get the pulley to run as true as possible when it's set and finished. There it is. I have the step machined into it. Here's my pulley. The bolt pattern is going to be a little different, but as you can tell, everything kind of lines up. This lip should be about 10 thousandths smaller than this diameter, just in case there's a little variance through these pulleys from different manufacturers and that. So there's a little bit of play in there. That's good. It all sits together. Got room for the bolts. Voila! Countersink these bolt holes and throw the other set screw in, and we are done. The final piece of the puzzle is to install a new set screw. I put a dot right there where it needs to be, which is 180 away from the keyway where the other ones are. This material is getting thin here, and since it's going to be for just a rod extension, you grind a flat on the rod. You can have a set screw really anywhere, and you don't have to worry about it marring up the rod and the rod not coming out. Eat my Wheaties. Bingo. To tap a 1/4-20 hole, we need number 7 drill bit. That's what I'm inserting. Ta-da! 1/4-20. Got a V block. And my part. Then a dollop of oil. Bingo. There it is, all tapped out, ready to go. All I need to do is blow the chips out, deburr it, de-oil it, pack it up, and send it to a Craftsman crusher. So that's the final overview of it. It's a fun little build, but I want to thank you guys for watching and have a good one.